Monsoon, Bsc, third year, paper. So now last class we're discussing 2 by 2 matrix eigenvalues. Now to 3 by 3 matrix. Find the eigenvalues, eigenvector. Find the eigenvalues and eigenvector matrix vector of the matrix equal to 4 minus 1 6 2 1 6 2 minus 1 8. So this is 3 by 3 matrix now. Now see here, sometimes they are asking proper values, characteristic values, Eigenvectors are proper vectors are characteristic vectors. Now, first you can write given matrix A equal to, you can write 4 minus 1 6 2 1 6 2 minus 1 8. 4 minus 1 6 2 1 6 2 minus 1 8. The characteristic equation of A is mod A minus lambda I equal to 0. So you can write the diagonal elements mod 4 minus lambda minus 1 6 2 1 minus lambda 6 and 2 minus 1 8 minus lambda. So whatever the diagonal elements are there, you can add the diagonal elements minus lambda and write the determinant. So that one I did that one here equal to 0. Now the first one is plus, next minus, next plus. 4 minus lambda into the determinant value. So here I can remove first row, first column. The remaining terms are what? 1 minus lambda, 6 minus 1, 8 minus lambda. And next minus into minus 1 into first plus, next minus delta. So middle term you can remove the remainder of this minus 2 minus 2 6 2 8 minus lambda 2 6 2 8 minus lambda and last plus 6 into the determinant. You can write the remaining terms. So all the remaining terms here you can get 2 1 minus lambda 2 minus 1. One way is you can multiply it. Other way is what we're discussing already, the shortcut method. You can do in rough. So what is shortcut method? The shortcut method is you can write this step. First step is compulsory, second step. While doing third step, you can write direct step minus lambda cube plus lambda squared. You can add the diagonal elements. What are the diagonals? See, I'm writing the matrix here again. 4 1 minus 1 6 2 1 6 2 minus 1 8. Now see here. The shortcut method always minus lambda cube. And you can add the diagonal elements. What are diagonal elements here? 4 plus 1 plus 8 lambda square minus. You can apply this lambda only. The lambda is you can multiply the diagonal. 4 ones are 4 plus 1 8s are 8 plus 8 4s are 32. First you can write plus minus of the remaining opposite diagonal. What are the opposite? 2 into minus 1 minus 2. 2 into 6. 18. 2 6s are 12. Minus 1 into 6. Minus 6. Right? minus plus minus. So you can write here now here minus minus plus minus plus that here. Can write it. Get A equal to 0. This is the procedure. Shortcut method. So first you can write this step in your exam, and second this step. You can do this one in at end of now, right? So you can write direct minus lambda cube plus what is the value 4, 8 plus 4, 12, 12 plus 1, 13 lambda square minus what is the value here 32, 40, 44, 44 minus uh, 12, 8 plus 6, 6 minus 2 is 4, 44 minus 4 is 40. 40 lambda plus determinant value. What is determinant value? So the normal determination only. Normal determination here looking at 4 into 8 plus 6 plus 1 into 16 minus 12 minus plus 6 into minus 2 minus 14, 14, 4 56 minus 6 4 4 6 minus 24. So here we can get 24, 30, 30 minus plus 56 is 30. 30 minus 56, 44, 56 minus 6 minus 24, 30. So we are having 26. 4, 8 plus 6, 10, 14, 14 was 56 plus 1 into 8 was 16, 2 6 is 12. Minus this is 4, I think 16 minus 2 is 4 plus 4 that 2. Here we can get 60 minus 24 is minus 36. So plus 36 equal to. So this is the equation. So this is shortcut method now. So hardly it will take just 1 minute. You can have direct step now, no problem. You get the full marks. Now we can write the equation, or else you can multiply normal AD minus BC to get this equation. So here finally you conduct compulsory in your exam this step, second step, and third you can write. You don't write this bracket function because they don't know this method. This is shortcut method. Okay. So I am multiplying minus here. I can get your multiplying minus lambda cube minus 13 lambda square plus 40 lambda minus 36 equal to 0. Right. Is it clear all of you? I think it's right. Copy it. Now, so this is the characteristic equation. So what is the equation? Lambda cube minus 13 lambda square plus 40 lambda minus 36 equal to 0. How we are finding the roots? 1 minus 13, 40 minus 36. You know, 36 means I can take lambda equal to 2 or 3 or 9. So I am taking lambda equal to 2 first, 0, 1, 1 plus 2 is 2. By using trial and error only, you can apply 2, 3, 4. 1, 2, 3 only, you can get the solution. Minus 11, 11 to 22 minus 22. Here, I think you can get 18. 18 to 36. If you are not getting 0, you can change this number minus 2. Okay? Now this cube is reduced to lambda equal to 2, comma lambda square minus 11 lambda plus 18 equal to 0. So 9 18 means 9 to 18 lambda square minus 9 lambda minus 2 lambda plus 18 equal to 0. Lambda is common, lambda minus 9 minus 2 is common, lambda minus 9 equal to 0. Lambda minus 9 into lambda minus 2 equal to 0. We can get lambda equal to 9 comma 2. So finally we can get lambda equal to 2 comma 2 comma 9. Be the eigenvalues eigenvalues of matrix A. See, the question is they're asking find the characteristic equation means you can write this is what characteristic equation or characteristic polynomial equation. Polynomial equation, right? Sometimes they are saying to write the polynomial equation, characteristic equation. Right? You can write this one, and this is what eigenvalues mean. Now here. This eigenvectors first we can find lambda equal to. Here we are having two where lambda equal to 2 times, but we can apply only one value. So lambda equal to 2, only one value. So find now to find eigenvector, to find eigenvectors vector corresponding lambda equal to 2. So we are given getting the value 2 times, but we can apply only one time by the definition. What is the definition? By the definition, A minus lambda I put in the matrix form into X equal to 0 bar. So A minus what is the matrix now? The matrix is 4 minus lambda minus 1 6. 2 1 minus lambda 6. Next 1 2 minus 1 8 minus lambda. The matrix anyway 3 by 3 I am writing X Y Z. Some other they are writing X1 X2 X3 also. You can choose any one. So put lambda equal to 2. So lambda equal to 2 means 2, 4 minus 2, 2 minus 1, 6. 2 minus 1, 6. 2 minus 1, 6. So X, Y, Z equal to 0, 0, 0. So same, rounding first element, make them as below terms are zeros. So anyway, R1, R2, make them as R2 equal to, convert to R1 minus 2R2 and R3 equal to 2R1 minus 2R. Or if 2 to cancel, you can write R1 minus R2, R1 minus R3 also. That's your wish. So finally, this topic. So finally, here we can get 2 minus 1, 6, 9 terms of zeros. So what is rank here? X, Y, Z? 0, 0, 0. So what is rank row of A equal to 1 equal to R, N equal to 3. Then the system is consistent. Then the system is consistent and it has infinite number of solutions. So n minus r equal, that is n minus r equal to 3 minus 1, that equal to 2. So you can take how many constants? 2 constants. Now applying this equal to, you can multiply this last equation only. So we can get a 2x minus y plus 6z equal to 0. Put n minus r equal to 2, put z equal to k1, y equal to k2. Can substitute here. Now see here, we can get 2x minus k2 plus 6k1 equal to 0. 2x equal to k2 minus 6k1, x equal to k2 by 2 minus 3k1. So finally, we can get the matrix x, y, z. Here we can write K2 by 2 minus K1 and K2 K1. The matrix you can take K1 is common. The coefficient minus 1, 0, 1. And the K2 is common. You can get 1 by 2, 1, 0. So these are the eigenvector corresponding lambda. Be the eigenvectors, eigenvectors corresponding lambda equal to 2. Corresponding lambda equal to 2. So here lambda equal to 2, how many times here we can get 2 times. Don't apply the 2 times here. Only here, in this case, lambda equal to 2, only one time only you can apply. Next, lambda equal to what? Next to variable here, what is next to variable? Next is lambda equal to, you can take 9. Suppose we're getting 1, 2, 3 means different numbers. Lambda equal to 1 time, lambda equal to 2 other time, lambda 3 times in it apply. But in this case, you can get only one time only. Okay. Yes. Now lambda equal to 9, I am finding lambda equal to 9. To find the eigenvector corresponding lambda. You can copy this one. To find eigenvector corresponding lambda equal to 9. So you can write by the definition. So by the definition, a minus lambda I into x bar equal to 0 bar. You can write the matrix 4 minus lambda minus 1 6 2 1 minus lambda 6 2 minus 1 8 minus lambda x y z equal to 0 0 0. So put lambda equal to 9. Substitute in that, we can get minus 5 minus 1 6 2 minus 8 6 2 minus 1 1. X y z 2 minus 1 minus 1. Here we can get 0 0. So rounding first for first element, make them as below terms 0. Yeah, lambda equal to 9 one time means you can get 1 row is R1, R2, R3, R2 equal to 2 R1 plus 5 R2 and R3 equal to 2 R1 plus 5 R2. Stop it. Three K1. It has 3K1 minus 3, sorry. So you can get R1 is, you can get R1 row is as it is, you can get minus 5 1 6, and the second row is uh, second row you can get 0 zeros only here, and the value minus 2 minus 40 minus 42 minus 42, and here 2 6 are 12 12 plus 30 12 plus 30 40, and here also you can get minus 2 minus 5 minus 7 minus 7. And here 2 6 are 12 minus 5 is 7. You can write x, y, z as it is. 0, 0, 0. And around in second for second, like the below element is 0. This is R2 and R3. R3 equal to minus 7 R2 plus 42 R3. So I can get minus 5160 minus 42 plus 42. Anyway, compulsory we can get rank is 2 compulsory. 0, 0, 0. If you're not getting rank 2 means you did somewhere mistake. Now row of A equal to 2 equal to R, N equal to 3. Then the system is consistent, and then the system is consistent and it has unique solution. Sorry, infinite number of solutions. Sorry, it has infinite number of solutions. Infinite number of solutions. So you can multiply this equation. So n minus r equal to what here? N minus r equal to n equal to 3, r equal to 2. So if you get 1, blank is 1. So n minus r equal to 1. That means you can get one constant. You can take one constant only. So minus 5x plus y plus 6z equal to 0. Minus 42y plus 42z equal to 0. So this is the last equation I'm taking here. So put anyway n minus r equal to 1. So put z equal to k. Then substitute here 42y plus 42k equal to 0. Anyway y equal to k only. Again, so anyway 42, 42 cancel. Get minus y plus k equal to 0. Y equal to k. These two are substituted in equation 1. So minus 5x plus k plus 6k equal to 0. Minus 5x plus 7k equal to 0. Minus 5x equal to minus 7k and x equal to 7 by 5. So the values, I think x plus 2, I think 2 minus 1. I think. This is minus 1, right? This is minus 1. This is minus y. So we can get here minus k. Minus k and here 5k. Yeah, this is 5k, 5k, k, x equal to k. And finally, you can get x, y, z equal to k, k, k. So we're taking k is common 1, 1, 1 with the eigenvector corresponding with the eigenvector corresponding lambda equal to 9. That's a simple problem. So don't do simple mistakes better. So this is eigenvalues and eigenvalues. So the questions they are asking in this only, the question they are asking, they can give, first question is they are saying that find the characteristic polynomial. So this is characteristic polynomial equation. Find the eigenvalues. This is eigenvalues. Next, find the eigenvectors. This is the procedure. Now, next, they are asking the question is lambda equal to 2 with the eigenvector, eigenvalue, then find the eigenvector for that. That means other time you can apply this one. So lambda equal to 2 means you can apply this part only this part. So like that only they are asking lambda equal to 2 only, not other one. lambda equal to 2 only, not other one. Lambda equal to 9 otherwise. So they are asking different types of questions in that. Okay. So like that, we'll discuss the next session. So in this session, I can give the homework problems, find eigenvalues. You can practice this one on eigenvalues, eigenvector. After that, how they are asking different types of questions. So homework is first question. Find the eigenvalues. Better to write characteristic values, and characteristic vectors of the following matrix. So first one, A equal to 1, 3, 3, minus 3, minus 5, minus 3, 3, 3, 1. Second bit, A equal to 4, 0, 1, minus 2, 1, 0, and minus 2, 0, 1. Next question. Minus 1, 4, minus 2, minus 3, 4, 0, minus 3, 1, 3. You can try these three problems, find the eigenvalues and eigenvectors. So, thank you.